Given the Fourier coefficients for this waveform, we have a of n for n odd, we have b of n, and we have our vp, we have t is equal to 5 milliseconds. Now we've actually done a homework problem that's very, very similar to this, where we actually find our a of n and our b of n and our av. But let's look at the av right here. So we know av means average value. So what we can do is look at the entire period. So period starts from 0 and it goes until it starts repeating. And so it starts repeating after t. So this is our entire period. Now the average is going to look at the area that's inside of our graph, and well, basically it's sandwiched between our graph and our wave. So we have this in here, we have this in here, and then we have this in here. Oops, sorry, we only have this because the period stops at t. It stops right here. So what we can see is that the area is going to cancel out, right? We have two positive sides, and then we have one negative side and one negative side here. So that means we're going to have an average value of 0 volts. And that's how we would do this first part. Now we're going to look at the second part. And for the second part, we're going to need this. We're asked to answer the next two questions in the order of magnitude, identify the cosine or sine, and the frequency of the sinusoid in radians per second. To do this, we would need to look at this. A dead giveaway is that we have these values right here. We have these numbers, right? These are our n values, or you can also represent them as k. K and n are used interchangeably. So we would plug them into here, and we can see that this is a summation. So we'll have to use this. Now let's make a general formula for our summation. For our summation, we're going to say that our v of t is equal to, we don't have any kind of like circuit or anything, so we don't need to worry about that. If we did have one, there's a previous problem linked below the like button in the playlist that deals with something like that. But if we're just given a wave like this, we are going to have basically our a of n. So we're going to be dealing with all of this inside of here. Our a of v is 0, so we're just dealing with this important stuff. So we are going to have our a of n, which we know to be the -8 vp and over n pi squared. So we're going to have that out front. We're going to have the -8. We know our vp is given to us as 50 volts. So we're going to multiply this by 50. We're going to plug in everything that we have. So we don't have anything that we don't have. We're going to have our n pi, and this is all squared. And this is being multiplied, we can see here by this cosine. So we're going to have cosine, and then we're going to have our n. So just n like this. Now we have our omega naught right here. We need to find our omega naught. Well, we know that omega naught is equal to 2 pi times frequency, or we can say 2 pi over the period, which is time. And our time is 5 milliseconds right here. So into t, we can plug in 5 times 10 to the negative cubed. And this is going to give us an omega naught of 1,257 approximately. And that is what we would plug into here. So 1,257. Be careful with rounding though. I'm just doing this very approximately. So, and then we're going to have our minus angle right here. We don't have an angle, so we don't need to worry about that. If we did have a b of n, we can see that our b of n is 0. We would have plus our b of n times the sine, and then we're going to have n omega naught minus the angle n here. But, oh, and this is all in the summation, right? But since our b of n is 0 right here, this means this is all going to 0 out. And so we can start plugging in our values. Let's do 1 first. So v1 of t, it's equal to, well, we are always going to have our -8 times 50, and then this is going to be divided by 1 times pi squared. So after we just do the first part right here, this is what we're currently looking at, we are going to get approximately 40.5, or -40.5. So this is what we're going to have here, -40.5, and then we're going to multiply this by the cosine, and then inside of here, our n is 1 for this specific circumstance, so we're going to have 1,257. And so this is what we have here. Don't forget, because I forgot, that this is being multiplied by t inside of here. So we should have a t like this, and that means we'll have a t inside of here. So when we go to write our answer, we'll have a negative 40.5, and then we'll have a cosine of 1,257 times t. So that's how we would do that one. Now let's look at the one for 5. It's basically going to be the same thing, we're just plugging 5 in. We're finding values here. So we are going to have the negative 8 times 50 divided by parenthesis, and then we're going to have 5 times pi in parenthesis, and then squared. This is going to give us negative 1.62 approximately. And then we're multiplying this by cosine. We're going to have a 5 in our n right here. So we are going to have 5 times our omega. We know the omega to be 1,257. So 5 times 1,257 is going to give us approximately 6,285. And then we have our times t here. We don't have an angle, so that's why we're not worrying about it in these. And now we can just plug in our answer. We're going to have a negative 1.62. This is cosine. The other possible answer was sine. And then we're going to have 6,285. Make sure you check these values if you're doing them yourself. You want to make sure that you don't have any rounding errors because I heavily rounded them just for simplicity here. But that's how you would go about solving this problem.